Hello all, welcome to the class of CACM. I am Sai Krishna from Department of Aeronautical Engineering from the Institute of Aeronautical Engineering. Today we will be discussing next topic on CACM, which is raster scan graphics. Right. First, let me cover what do you mean by raster scan and where does it come basically. Is first, before going to raster scan, we'll see how we will be displaying a screen. Right. Basically, whenever, as we discussed earlier, from cathode ray tubes, CRTs, when an electron touches your phosphor screen, it emits a light. Right. Now, based on changing the direction of this particular electron, we can write a complete set on a screen in form of simple stroke. Right. A simple stroke, it consists of a line. After you are done with your horizontal part, next second, third, fourth, in any way, right? By changing the position or the direction in terms of horizontal as well as vertical, doing the same to control the direction of your electron, you will be writing it in terms of, you will be writing and getting a picture in terms of lines. Now, this in the same case, as the technology progresses, we require a higher quality picture as well as higher good color quality. For that, what we have developed is basically, we have developed a raster scan graphics. How this will be working is, basically your TV screen will be divided into number of cells, also called as pixels, right? And the spacing between them is your dot pixel, right? And in between that every pixel cell will be having a specified amount of data that to be projected, right? It can be altered or readjusted according to the according to your values of the picture densities, right? Now, in the same case, for example, we'll consider the example that already been shown. We'll consider this small display set on to which you have a number of cells, which is also called as pixels, right? Now, whatever the controller or the display processor, what it basically does is it projects a dot, right? It projects a dot if there is a picture to be shown at that particular point, and it scans horizontally. Again, then go for your next line, right? Now, what happens is basically this will be done right in an orderly manner, right? The lines will be scanned in an orderly manner. For example, right, from starting with your point A, the picture will be defined in terms of point A to point B in the term of your pixel definition. Then again from point B, again it will go for your second row at A dash, again to B dash, next A double dash, B double dash, C triple dash, sorry, A triple dash, B triple dash, right? In all the ways, right? The picture will form a line after the line and pixel after the pixel based on the quantity of electron or quantity of the image data that you are putting up by bit. So based on that, your image is being formed. Similarly, in some cases, for a low resolution or low pixel, microcontrolled processors, for that, what we'll be doing is basically we'll be skipping these intermediate lines, right? The processor will skip from intermediate lines, particularly called in this manner, right? It will directly jump on to your line 1 to line 3 and line 3 to line 5, basically, right? Now, this phenomenon is called interlacing, right? It is basically skipping an intermediate line or intermediate pixel line through which the picture is not being generated again. Now, in order to create, now whatever we are generating is basically a standstill picture. Now, whenever we want to generate a high quality or a moving picture at the time, the same thing, whatever we discussed earlier, which is your lacing methods, right, from one line to other, will be done frequently over a period of time or per second, which we also call it as refresh rate, right? This refresh rate is basically means that your whole screen, particularly what we have discussed here, this whole screen gets image refreshed, right? Image data at every cell will get refreshed every 60 times or 30 times based on the refresh rate that the microprocessor or microcontroller is capable of. For example, whatever our mobiles or whatever we are televisions that we will be using, that will be of either 120 hertz or 60 hertz or 240 hertz, right? Or sometimes it can be 30 hertz also. These are your various frequency ranges through which the refresh rate occurs. Now, how does this refresh rate varies? Basically, what it will be per hertz is basically per second, which means 60 times, if you're considering for 60 hertz, 60 times the screen is getting refreshed per second, right? Now, during this 60 times, it's not necessary that complete picture of the screen is to be refreshed. Some part of the picture can also be refreshed based on the capacity of your microcontroller. For in order to cover that, what we'll be using? We'll be using interlacing, as we discussed earlier, right? Now coming to your pixels. Pixels will also basically vary from your screen to screen and type of display that you will be using. For example, your 1024 into 1284 somewhere around is your one type of pixel density that is commonly available for your LCD monitors as well as your TV monitors, right? Sometimes if you're going for some 4K or full HD, in those cases at the time this number will increase to 3000 to 2000 something, right? It's an approximate value I am giving, but you can find it out better whatever televisions or screens you are watching through it, right? So basically that will give you a density on which the pixels are made, and based on the pixel density and based on your frequency rate or refresh rates, the picture whatever is being generated will be most accurate and sharper to be visible. Now coming to your colors, right? How does a color can be shown under your pixel? Basically, if you're using if you're using raster scan system for your basic graphics, that is to be black and white. At that time, what happens is basically you'll be putting either black or white or a mix of both at certain proportions, right? In certain proportions to get your colors like gray or grayish white, right, etc. Now, how how does the camera know that a certain proportion or certain mixture is to be done? Is based on the image data that you will be giving to the processor to process and display onto your display screen. This part we will discuss later. In the same way, if you're going for color, which is under mode of RGB, which stands for red, green, and blue, right? Mixing all three colors at a certain proportions and certain intensities will give you the required color density that is required at each pixel, right? Whenever this raster scan, what it does basically is it converts your vector form into a pixel form, right? Whatever the pixel or vector form, whatever we are having, whatever pixel form we are, vector form we are having, let's say for in terms of your data as well as your electron, that will be converted into your pixel data for each cell that we have discussed earlier. Now, based on this pixel data, what happens is if you want to form a line, right? If you want to form a line, you will be getting a straight line by illuminating a pixel one after the other, right? In some cases, if you want to create a curve, at the time you will be creating an inclined line based on your pixel densities again, right? Now, if the pixel density is higher, in those cases, what you will be having? You will be having a higher resolution screen which provides you a smoother curve as on when required, right? Or increasing the algorithms through which this curve is being formed. Basically, under raster graphics, you will be having two types of algorithms that we will be discussing further, right? Now, how does the raster scan graphics, particularly any graphics, particularly which follows the raster scan model, will be generated, right? First, the data from the main processor goes to your graphic processor, right? Any data that is stored either in the memory, it can be primary, main memory, or an auxiliary memory, which is being stored is sent to your main processor. From the main processor, it is being sent to a graphic processor to get a clear idea or to identify the color density as well as the pixel count or the density, the position of that particular color at the whole pixel. Next, a frame buffer is a temporary storage onto which this data, image data, is being stored in a form of pixels, right? Bit by bit. Next, in the same data is being sent to your sweeper which sweeps the whole screen, right? Sweeper which sweeps the whole screen pixel by pixel, pixel by pixel to clear out an image or to give out an image, right? Then it will create onto your display, right? In this, the sweeper will get synchronized with your graphic processor to make a follow of how does the data is being displayed onto your display device and to your and which data is being to be followed next. This synchronized data will keep your frame buffer with a small storage volume so that it can be processed better. In the olden ages, not particularly now, where the microcontrollers are not that much proficient, at that time what happens? The main process is directly in connection with your frame buffer to control the image data directly. Nowadays, as we are uh, providing or we are getting the new microcontrollers as well as microprocessors for that, what we are using graphic processors to enhance the picture quality which is being displayed, right? Next, as we have discussed earlier, these are our three algorithms that we will be discussing on which the raster scan graphics will be functional, right? First is nothing but your DDA algorithm. What does the DDA algorithm mean? Basically, it is the first algorithm which is being developed for rasterizing the vectorial information. What do you mean by rasterizing? As we have discussed earlier, conversion of your vectorial data to your pixel form. Vectorial data to your pixel form is your rastering. Now, this vectorial information is whatever you are representing onto your pixel, right? As discussed earlier, now these particular algorithms are developed only for two particular geometries, basically a line and an arc, right? Now, under line, in same as your raster graphic, if you want to represent a line, the line can be split into number of pixels and can be positioned accordingly for the image data that you want to display. When you want to position a curve, at the time, this data is supposed to be shown in multiple forms to get your curve in, right? Similar to your previous example in this case, right? This is your case, right? If you want to show a curve of a circle, you are supposed to create a line which is inclined on both ways so that your final value will be your final curve. Whereas for a straight line, you can directly point it out whether it's an incline or horizontal or vertical, right? In all three ways. Now, what happens during this is basically DD algorithm will just create a line pixel dot for every image data that is being generated, right? Let's say for the same example, if you're considering this area of your pixel sheet, this is my dot or this is my image that is being manufactured. If you are going for a straight line, one after the other, the pixel is being added and refreshed according to your refresh rates to maintain that picture on the screen. Suppose if you want to create a curve, what happens is basically from point A, let's say from point B, you want a curve, right? So what it basically does, if it is on a single path, you'll be getting the same line similar to what we had discussed earlier, right? If it's required a small curve of particular radius, at that time similar to your circle, at that time also you'll be getting an alternate pixel, right? Similar to your incline, but that will be not be your actual curve. That can happen, right? Basically, that curve is supposed to be as smooth as possible, which everyone knows. So, in order to do that, what you can do is basically there are two ways. First is to increase the pixel density so that instead of converting a single pixel or vector data to a single dot lines, we can just convert the same to a more denser pixel sheet so that within the small volume of pixel sheet you can get a clear or sharper curve based on your requirement. Now other thing is a small development in the algorithm itself where you will be removing the floating point arithmetic, right? Now in this, what happens basically is, let's say for this part, so not this, for the same curve, what we were discussing till now, this line, right? Based on this line, as our geometry require, based on the image quality, what happens is this dots will be shifted accordingly to the curve that is being required to us, right? Let me just redo. Bisham's method, Bisham is the name of scientist, is an improvement over DDA since it is completely eliminating or eliminates the floating point arithmetic except for the initial computations. As the picture is being generated over a period of time, for example, as for the initial picture might not have the same quality or same curve what we have discussed, but later on, as it is getting refreshed for a period of time for 2 seconds, 3 seconds, or 5 seconds, at that time you will be getting a much sharper picture and much curved region as your algorithm suggests. Now, Bisham methods basically needs more amount of computational time. So, in order to apply this particular algorithm, the TVs or any display units are supposed to be having more amount of computational power to maintain that picture quality over a period of time. Now, coming to anti-aliasing lines, in this method, the intensity of pixel is made proportional to the area of pixel covered by thick lines. For example, this, right? If you want a line inclined, not in the horizontal vertical, but at some angle. What happens during this is, whenever you're using the raster scan graphic method, you'll be creating a line which gradually increases to achieve your required angle in an average. But to be precise, that is not your actual display or actual line that is supposed to be drawn. So for that, as we discussed earlier, two ways. First is your graphical method, or sorry, first is your increase in pixel method or increasing your pixel density. Second is your assuming or appropriating a value for the nearby pixel cells that you require. For example, you are creating a line from A to B at an angle of some, let's say 30 degrees. What happens during this is pixel will be formed, right? These are your pixels that are logically formed based on your line that you want to be drawn. Now in this case, what happens is the line in form of pixels, as we are seeing here, is not as accurate as possible, right? For those cases, what you are using? You are using the anti-aliasing lines algorithm to increase the intensities of the pixel, right? Increase the intensities of the particular pixel to get your line as inclined and as straight as possible, right? We will be increasing the intensity of each pixel to get a line as straight as possible as and when required. Now, as anti-aliasing is also required more computing power, depending on the requirement, we will be using the same. Next is your LCDs. LCDs, how the LCDs will work? First, they will be having a light source, any simple LEDs, right? Next, we will be using polarizing filter, which polarizes the sunlight which you are getting from outside. Next, you will be having an electrodes which accelerate the light or direct the light accordingly as and when required, and your liquid crystal, right? Liquid crystal consists of, particularly liquid crystal display will contains of pneumatic crystals, right? These are crystals which are oriented under your solid and liquid suspension or simple mixture, right? These are these can be oriented by applying a small electromagnetic field or electric field towards them, so that they act as a polarizing filter to filter out the light that is being coming out of your light source, right? Next, as on when required, these are again passed through your electrodes onto your coloring filters to get your actual color onto your, then to your polarizing filter onto your display surface, right? Now in this case, we'll see one thing. In your liquid crystal display, first a light source is being emitted, which is being polarized first, means to remove the either one of the directional waves of your electromagnetic wave, then are being sent to your electrode particular to potential field based on requirement of your picture. You can control the electrode densities through which a light is getting passed through. Then from the electrode, your suspension, what we have discussed earlier, your crystals, right? These crystals are kept under small cells, particularly liquid cells, which are connected all together. Now, based on the requirement of the picture at particular pixel quality, particular pixel, what we will be doing is we will be adjusting the small electropotential along this cell, right? This cell containing your pneumatic crystals, as we have discussed, will be orienting themselves to create a small or temporary polarizing filter to block out the unwanted light, right? To block out an unwanted light, during which only the wanted light is being again sent back to your electrodes onto your filter, then again filter, which consists of the color as well as polarizing, then to your display, right? Now in this whole process, what is your key component is basically your control of your pneumatic structures or pneumatic crystals in a liquid suspended solid crystals on it, right? Now these crystals are basically controlled due to your electromagnetic field and according to your input signal or input picture signal that is being generated over a period of time. Now in this, what is your basic is polarizing filter. Why there is a use of your polarizing filter front as well as back, right? Your light source, which can be any, basically emits complete white light, right? A complete white light which includes all the colors of your rainbow, right? Which also includes your electromagnetic waves. Now these are getting filtered here from a polarizing filter to get a pure light onto your electrodes. Now this energy is getting filtered back in cells based on the input that is given to the user or given by the user to the screen. Then that is being again accelerated in electrodes onto your colors to filter to provide a color display. Then again are filtered for unwanted any colors or any unwanted rays using a polarizing filter. Then the picture is being getting displayed onto your surface. Right now, this will be your process for your liquid crystal display. Now, coordinate systems for your geometry. Now, for every system, what we'll be using? We'll be using a right-handed Cartesian coordinate system, which are used for defining geometric part. In this, basically, any designer would be using three types of coordinate systems. First is your world or model coordinate system. Second is your user or working coordinate system. Third is your display or screen coordinate system. In this, first, world coordinate system, we'll discuss all three, right? With an example, let's say if we consider this as a part, right? Under this part, if or any part, this part starts with the origin that is being defined in your CAD software, right? Which is common coordination system for all the edges as well as your vertices, right? Now this system is called your world coordinate system. To be precise, an actual coordinate system used as a master for the component. This master coordinate system will not change without in respect to any of the other coordinate system or any of the geometry. That remains same irrespective of the geometry that you are being created. Now coming for your next is user or working coordinate system. For this coordinate system, you will be defining a coordinate system, particularly in this case, it stands for x, y, z and z, z dash, which is parallel, right? Which is parallel in accordance to your primary Cartesian system, right? For example, I want to create a sketch at this face, right? At that time, what I'm supposed to do, I'm supposed to define a new coordinate system for my convenience, right? A new coordinate system for my convenience at this point to get my sketch out. So, in order to cover this, what we'll be doing is we will be basically creating a new plane or new coordinate system in accordance to your master one. In accordance to your master one to let the user work freely in accordance to his own work, right? Now, and the last is your display or screen coordinate system. These are your actual coordinates that are used for displaying the image on the screen, right? For example, if what we are discussing is this is on my screen, right? For a 2D image, you will be using in terms of x and y, right? Now, in this same x and y, what we'll be doing is we'll be dividing, coming to your raster scan, we'll be dividing it in terms of number of pixels, which gives you pixel density of the screen, right? Based on the pixel density of the screen, a picture is being generated onto the screen that you are seeing now, right? Now, in the same case, these are your coordinates which are actually displayed or which are actually used for creation of images on the screen, right? Whatever you are seeing now for me, for example, this is being created by its own reference system and letting it know that this point tip is getting at a particular section on the screen at this particular coordinate. That data is being sent from the microprocessor onto your frame buffer, then to your screen, right? and the sweeper will let the onto the display that this is my point that is being displayed at, is supposed to be displayed at this particular coordinate. Nowadays, what we are doing is we are using a graphical processor, as discussed earlier, right? We'll be using a graphical processor to point out or tell the machine from a microcontroller's instruction that this dot is supposed to be coming at this particular section or particular coordinate data of the screen display for this particular intensity, right? Everything will be given based on the data that the picture quality has, and from the microcontroller it goes to a graphic processor, which again in turn tells your frame buffer, then down to your sweeper. Sweeper sweeps your display unit, then tells the frame buffer or from a graphical processor that the screen is clean, where you want me to put my image. So sweeper will sweep the screen entirely at the already predefined refresh rate to get out a more clear picture as well as a moving picture. Right? Right? So for with this, we'll be stopping for now. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.